Hello everyone, my name is Steve Rehse. I'm the head of the Department of Physics at the University of Windsor, and I'm really pleased that you've decided to spend a little time with us to learn more about the programs that we offer in our department. It's time for some physics, so let's see if we can learn why it is that so many people find physics interesting and what it is that our students do after they get their physics degrees. The first thing I have to say is that being fascinated by physics is a very natural thing. There are a lot of people in this world who are really interested in the ideas that physicists get to study every day. In fact, one of the things that makes physics so interesting is that it's the foundation of all modern science, and people love science. It's a study of the natural universe that really allows you to try to understand how things work. And the physicists get to study all the coolest things in the universe. We study the largest things like galaxies and galactic clusters, and we study the smallest things like the structure of matter, the atoms and the nucleus, and the quarks that are inside the nucleus. The concepts that we get to study are really interesting as well. We get to study mind-bending things like relativity as developed by Albert Einstein and quantum mechanics, the world of the very small. The things that we study really do challenge the imagination, and also they're a lot of fun to think about. I would say importantly though, when you study physics at the University of Windsor, you're not going to get to learn just all those cool things about the universe. We're going to teach you some really fundamental things. Like importantly, we're going to teach you how to ask questions, which will allow you to better understand your world and your universe. You're not just going to learn equations and math and computer coding. You're going to develop your mind. You're going to learn to think. And most importantly, you're going to learn to learn. If we've done our job right, by the end of 4 years with us, you're going to be able to teach yourself any subject you want, which is going to make you a really useful and productive member of society. And importantly, don't just think of this as 4 years of your life and then you're moving on to something else. You're going to use the skills that we help you develop for the rest of your life, no matter what field you go into. This is really a case of lifelong learning. It's not just going to stop when you leave University of Windsor. You're going to carry this way of thinking forward with you for the rest of your life. So along with studying a lot of really cool ideas and becoming very interested in how the universe works, you're actually going to pick up some really marketable skills as a physics major. It turns out that the things that we teach in our physics programs and in our physics department as you're learning these topics make you a really valuable member of society, particularly if you're interested in high-tech employment. So what are these skills specifically? Things like advanced mathematics, of course, always useful in the most high-tech industries. Computers and simulation. This is part and parcel of what we do in a physics department as we do our research. You're going to get at coding, at computers, and simulating phenomena, and that can be used in so many different fields in today's economy. Problem solving is one of the most important skills that any employer wants. They don't want to have to be able to tell you how to solve problems. They need a person who can think independently, tackle a problem, and get it solved. Physics is all about problem solving, and we put a high value on developing that skill. You're going to get good at working in a laboratory and experimental skills, designing experiments, setting up apparatus, recording data carefully, analyzing that data. These are going to be super useful to you if you're going into any science technology related field in your future. And of course, technical communications. Physicists place great value on being able to talk about what they've done, to be able to write it up clearly, to be able to advertise it. This is really important. So it's not just that you're doing work in a lab or an office that nobody knows about. We're going to make you a better communicator so you can then promote yourself, your job, and anything else that you need to do. No matter what you do after UWindsor, there's a couple of these soft skills that all science students acquire, and you're going to need them. These are really important. Communication skills, problem-solving skills, empathy, professionalism. All of the programs in the Faculty of Science at the University of Windsor are going to place a high emphasis on developing these 4 skills. In fact, medical schools and law schools specifically ask about these skills that you have when you apply for them. And you're going to want professors who are able to vouch that they've seen you demonstrate empathy and professionalism and problem-solving skills. So not only are you going to develop these skills at the University of Windsor, but you're going to have strong mentors that are going to be able to help advise you, develop these, and also vouch for the fact that you actually possess them when you're ready to move on to the next stage of your career. Along with these really important soft skills, you're going to acquire these other skills as well. You're going to learn how to focus on what's in front of you. You're going to learn how to work hard on material that's presented in front of you. You're going to have to be independent, do things on your own, get that homework started on time, get it turned in on time. You're going to have to be self-reliant. Can you work through these things on your own? You're going to learn perseverance. Things are going to be tough at times, but that's okay. That's the way you develop your confidence. Confidence in yourself that no matter whatever is going to be put in front of you in the future, you're going to be able to handle it. These are things that all students with a science degree at the University of Windsor are going to acquire. I believe that the students coming out of the Department of Physics have all these skills and actually succeed more than they even anticipated they would when they came into it. But how do I know that our students are actually succeeding after they graduate? Well, I just take a look at where they wind up. This is a snapshot of where our alumni, people who have graduated from our department, have wound up. And if you look at the jobs that our graduates have taken, you're going to be really surprised because you might expect it to say physicist, 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 but it really doesn't. Physicists wind up going everywhere and doing everything. Look at the types of jobs they take. Physicians, medical doctors, lawyers, university professors, video game developers, data scientists, high school teachers, data scientists at credit card companies, optical engineering, actuaries, quantum computing, medical physicists, staff scientists, computational physicists, optical engineers. All of these jobs are doable by a person with a physics degree. They're great jobs. They've taken them all over the world. They pay really good. And moreover, they're really interesting to the people who go into them. So I see physics as a way to find careers that are going to fascinate you and allow you to get into those careers. So that the graduates that we produce have been really, really successful in the past. How is it that we prepare our students to do so well? To what do I attribute that success? Well, probably the number one thing has to be that we have a lot of smaller classes with a very close-knit student body. We have about a 10 to 1 student to faculty ratio in our department. So all the faculty are going to know who you are. We're going to want you to get a faculty mentor as soon as you can and do real research in their labs. The upper year classes are 10 to 20 people maximum. They're not going to be competitive. You've got a built-in support system of students who want you to do well, and they want to do well as well. So you're going to help each other. We have a very active physics club that helps with outreach, service, entertainment, social activities. You're never going to be alone in the physics department. And that's really the thing that draws most of our students to our department. They want that feel of a smaller department that's really going to kind of take care of them and keep a lookout for them. It's going to help them be much more successful in their future. Because we're that size, as I said before, we're able to get you involved in world-class research really early. I would say no one matches our commitment and ability to involve undergraduates in real world-class research. Now, I don't know what you think a physicist looks like, but when I think of a physicist, these are the people I think about. These are real undergraduate students who are doing real work in real labs on experiment, computers, or theoretical physics with faculty mentors. These are people who don't have undergraduate degrees yet, but they're deeply involved in doing this work and doing professional physics with a faculty advisor. Many or most of these students get paid to do this work, sometimes in summer internships, sometimes during the semester. Many of these students can get classroom credit for doing this work. This leads to things like traveling nationally or internationally. This leads to publications, getting your name out there. It's so critical to taking the next step of a career in academia or physics. This contact with a professor and ability to get into his or her research lab is going to be crucial. And I think we're the best in it in Ontario. So this is the way I think logically about why it is that we produce such great graduates. We have smaller numbers in our programs. Those smaller numbers lead to greater access to research opportunities. You're not competing with 500 other students to get that great position in a great research lab. It's maybe just you and a couple others, and they've probably got room for all of you. If you want to get involved, you're going to get involved. That's a greater ability to acquire high impact experiential opportunities in the lab, traveling, doing physics. And most of our students are going to graduate with job-ready, life-ready skills and experiences due to that research opportunity and contact with the professor, not just the classes. The Faculty of Science at the University of Windsor is fantastic for that. We have about a 1 to 17 faculty to student ratio, the best of any science program in Ontario. We have greater than 65% undergraduate participation in research. It is the norm at the University of Windsor that you're going to be involved in practicing the science that you want to study almost from the first year, not just reading about it. We have students working alongside some faculty, and so let me quickly just take a minute or two to give you some examples of what is the type of science that we're doing. So a quick example, we've hired 3 what I would call superstars of research in the last 3 years, and they surely want and need your help to be doing their science with them. This is Professor Dan Zhao. She's an expert in MRI, which is magnetic resonance imaging. That's something you get at a hospital to do scans on you. This is Dr. Zhao with some of her students in her MRI lab, and here she is installing her small animal imaging MRI. In her vision of the future, MRI is not something super big and expensive and that you have to drive hours to get. It could be a small apparatus that's in an ambulance, or maybe even something so small you could swallow it in a pill and it can do MRI and image you from the inside out. That would be an amazing medical achievement. Here's another example. Here's Dr. TJ Hammond. He's an expert in ultra-fast lasers. What does ultra-fast mean? Well, the fastest thing your phone's camera can see is something that takes about a millisecond. Like, here's a sparkler. You can see the sparks coming off. That's a pretty clear image. But Dr. Hammond's ultra-fast lasers can see things that take a billionth of a second to occur. That's roughly the time it takes for an electron to orbit inside an atom. Incredibly fast. The students that he works with him work in what's called the Attosecond Condensed Matter Experiments Lab, or ACME for short. This whole field of study is essentially a brand new branch of physics that we call attoscience, and it was awarded the Nobel Prize in Physics in 2018. Dr. Jeff Rao is an expert in novel magnetic materials that haven't even been invented yet. What's a novel magnetic material? Well, a lot of people know that salt is a crystal, like this, and snowflakes have crystal structures. But Dr. Rao, as a theoretical physicist, explores how the geometry arrangement of atoms within some sort of crystal could control their properties. So he uses math and computations and equations. And by doing that, these physicists essentially invent exotic and unconventional phases of matter that can't possibly occur in nature, but can be fabricated in a lab once people know what they're looking for. So this way of thinking about the world was actually awarded another Nobel Prize in Physics in 2016. It called for theoretical discoveries of topological phase and transitions and topological phases of matter, a very exciting cutting-edge area of physics. Man, I hope some of that sounds interesting to you all. We really need your help working on these projects that are going to take physics into the 21st century. If you want to study physics with us, there's a few things that you probably need to do. We do have some minimum entering requirements. In addition to grade 12 U English, we require advanced functions and physics. So make sure you take those in your grade 12 year. It's strongly recommended you take calculus and vectors because you're going to be seeing a lot of math in your future. Chemistry is recommended. I can assure you that it's required for all physics majors, so you might as well take it. The minimum entering average for admission is 70%, but the mean entering average, the last time we had statistics for it in 2019, is actually 89%. So you can rest assured if you come to the Department of Physics, you're going to be surrounded by really good students who are dedicated to working hard and are going to help you work hard as well. That's a really important thing to note when you're trying to pick a program. What are the other students in the program around you going to be like? Are they going to help you achieve your goals, or are they going to get in the way of achieving your goals? Our students are all there to help everybody else. If you enroll in physics, you have to choose one of 2 programs: Honors Physics, Bachelor of Science, Honors Medical Physics, Bachelor of Science. Both of these options can be taken with a thesis or with a co-op option. In addition, all of our students in physics get a minor in mathematics. Students can also do a combined honors degree. Our most common combined honors is physics and computer science and physics and mathematics. This is the equivalent of what people would call a double major. We call it a combined honors degree. You might want to explore those options if you're not sure which specific field you want to study. In short, science is the no worries choice. Physics students can trivially switch between physics majors using a smartphone app. Coming into science is just the right choice. You don't have to worry about making a wrong choice in science. You can switch between majors, switch between programs. It's the no worries choice. Good luck. Thank you so much for joining me.